Okay, so remember 1 radian, listen please. 1 radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius of the circle. We went through that yesterday. Okay, how do we find the measures of other angles in radians? So the circle shown has a radius of r. We don't know what it is. We're just calling it r. The length of this arc has been measured to be 3 times as much as r. Okay? Then the radian measure of the central angle will be what? It's that ratio. Arc length divided by radius. So 3r divided by r is 3. Okay. Think about it. If I extended this across, pi is 3.14. So it's close to 3, right? We didn't measure it with a protractor exactly. We don't know what that measurement is, but it's pretty close, right? So arc length divided by the radius will give you the angle. That's your lesson for today. We're done. Not quite. That is really what it is. Okay? So, here, in this triangle, in this circle, arc length we're calling A. A for arc length. Big surprise. R for radius. So, arc length here, so the angle, central angle, is going to be arc length divided by radius. That's your lesson for today. We're done. Okay.
For real this time?
No, but that's what the formula you're going to use. That's going to be on your formula sheet. Do you want to memorize it? It helps. Do you want to rearrange it sometimes? Absolutely. Depends what you're looking for. Okay, listening please. Bianca. Okay, so the way in my head I have it memorized is I actually have it memorized as A equals R theta. Maybe I learned it that way. I don't know. That's just rearranged. Okay? Don't look perplexed at me. Right? If I solve for A, I'm multiplying by R. So sometimes you're going to want to solve for the arc length, given the radius and the central angle. Sometimes you're going to want to find the angle, given the arc length and the radius. Biggest thing of this lesson, so I'm doing this pretty fast because it's pretty straightforward, but the angle that you use in that formula has to be in radians. It doesn't work for degrees. Okay? So you must convert to radians. You can convert right in your calculations if you want. You can put in here, say, 42 degrees, and then put multiplied by pi over 180. Okay? Because you certainly don't want to put a rounded number into a calculation. Okay? But in any case, here it kind of summarizes the radian measure of any angle is equivalent to the measure of the arc length divided by the radius. If those are equal, the arc length and the radius, then the angle is 1 radian. Okay? And we did that already in the first lesson, remember? And then I had about 6 of them, a little bit more than 6 of those 1 radians. Okay? If A is the length of the arc subtending central angle theta in radians, then A equals R theta. So that's the form that I tend to remember it in. But as I said, your formula sheet has it theta equals. But I don't think it puts the word radians in there. So you have to remember that it's radians. Okay, so let's do just a couple of these. Measure of angle AOB in radians. So you're always going to assume the angle that gives you, if you're given an arc length, you're going to assume you're going to find that angle as opposed to this one, unless maybe it says major arc, AOB. We talked about minor and major. So in this case, we have the radius, so this is A, this is R, so theta is 6/3 is 2 radians. That's it. Okay, circle has radius 5, you can label it. Arc subtending the central angle theta has a length of 22. So try to make it kind of, think about, if that's 5, then this would be, say, 5, 10, 15, 22, I don't know, something like that. So find the measure of that. And again, so I'm finding the angle is not the minor angle, it's the one that is subtended by the arc length given to you. So this, we're finding theta. And does it say to, doesn't say to round, right? So it won't be that. I guess if you did, it would be what, 4.4. Okay. Just want to get to a couple of the, so let's leave this for right now. I want to get to a couple more of the applications. Okay, so this one we're given the central angle, 13 pi over 15. So think about that. If I draw, say, look, I draw my initial arm here. It's really that angle can be anywhere. I just tend to think about it because I think of standard position angles. 13 pi over 15. Is that less than 1? 13 over 15. Yep. Is it greater than a half? Yes. So you know it's going to be equivalent to second quadrant, maybe something like that. Okay. So that angle has an arc length here of 52. We need to find R as an exact value and then round it. So theta, remember, is A over R, or A equals R theta. So R will be equal to A over theta. A is 52. Theta is 13 pi over 15. It says exact value first. So that's going to be 52 times 15 over 13 pi. The pi is now in the denominator. Don't be lazy and put it in the numerator by mistake. Okay? So I flip this and multiply. 13 goes into 52 4 times, I think. Okay, this is, what unit is this? Inches? Or, no. Okay, we're finding the radius. So make sure your units are correct, right? Don't put radians. Don't leave it blank. It's the radius, which is a linear measurement. That's exact. Don't put the pi up with 60. And then decimal form would be 60 divided by pi. Nineteen point 19.10. So that angle was already in radians, which was nice. We didn't have to do any converting. But exact value has pi in the denominator. It might happen. And the last one I want to do, well, I'm going to draw this for you, and you can finish it. So 2 points A and B lie on a circle of radius 8. So we go radius of 8. I'll call this A. This is the center. And B is somewhere along here. It says angle OAB is pi over 6. That's a pretty small angle. So I'm going to maybe draw my B over here. Okay. So AOB, that's saying that this angle here is pi over 6. Okay. Yep. The middle letter is where the angle is. So OAB, that's your pi over 6. Back to math 9. Circle geometry. Okay? What's angle OBA? Actually, it's not even circle geometry, except for the fact that, what do you know about the radius? Is the radius the same throughout the whole circle? Yeah, otherwise it's not a circle, right? So this is this. What kind of triangle is that? Isosceles. That's a weird word. Isosceles triangle means that this angle is the same as this. Okay, so try to deal in radians. You can convert them to degrees. Guys, you can convert pi over 6 to degrees. What is it? Pi over 6 in degrees. Say it out loud. 30 degrees. Memorize it. Know it. 30 degrees. So you're at 30 degrees, 30 degrees. What's the angle at the center then? 120. Angles in a triangle add to 180. If you don't remember that, you're going to have a difficult time. Okay? So, 180 is pi. If you're dealing in radians, you're going pi minus pi over 6 minus pi over 6. This is 6 pi over 6. Minus 1 is 5. Minus 1 is 4. So this is 4 pi over 6 or 2 pi over 3. Okay, so that's your central angle. So now we're wanting to find length of AB on the circle. So that's arc length. A equals r theta. Radius is 8. Theta is 2 pi over 3. Okay, and this would be in centimeters. Okay, here's 100. 16 pi divided by 3. So I ended up doing this whole question, but anyway. So some properties there from circle geometry. Well, really, actually not from circle geometry, from triangles. Just remembering that the radius has to be the same throughout a whole circle. Otherwise, it's not a circle. Okay? And then I wanted to look at the last one, the merry-go-round, I think it was. Okay, so let's quickly go through that. Merry-go-round, do you remember going on a merry-go-round when you were young? No. Do You know what I mean by merry-go-round? At the park, you go up and you merry-go-round. Someone spins you around, right? So you can run on it, a little bit dangerous, or you can stay in the same place, right? And so we're trying to figure out if you are a child on the edge of it, how far physical distance you've actually traveled when you've been spinning around on the merry-go-round. That's an arc length, okay? So here, this radius is 5.6. Oh, and in this case, sorry, it tells you that the child has gone 300 feet. So the kid is here on the edge, keeps traveling around till a total of 300 feet. So this is the arc length. Okay, this is the radius. It says determine the total angle of rotation. So that's theta. So theta equals A over R. Arc length is 300. Radius is 5.6. Just make sure they're in the same unit. Seeing very similar one on the diploma exam, like this. Oh, it doesn't like me doubling up. Okay. .6. I'm going to record that here. Radius. Okay. So total angle of rotation in radians, rounded to the nearest tenth. In degrees, don't use the rounded. So that's still in your calculator with a bunch of decimal places. Converting that to degrees, remember that's radians, so we want to multiply by 180, divide by pi. Okay. If we knew that, how would we figure out how many rotations? Divide that by 360 or the radians by 2 pi. Okay? Okay, that's where I'm going to stop it.